the Coriolis force or the Coriolis effect, how the things change on rotation depending where you are on Earth. Okay, we all hear about this, but seems that we never get it. This is because it's a counterintuitive phenomenon. And today, in ocean science, I will clarify these ideas. So we can start from the beginning with Gaspard Gustave de Coriolis, French scientist, the first one on describing this effect in the 1835. Studying the different rotating objects. He wasn't thinking on Earth, but these maths can help to understand how the motion works in a spinning planet. So Coriolis is an apparent deflection of the objects, like the air or water, in a spinning surface. And this last part is important, so spin or rotation of an object. Keep this in mind. So as we know, the Earth can be something similar to a sphere, and this can be divided in the north and the south hemisphere. And here, with the rotation that this planet has, is a spinning object, so we can understand it with the maths from Coriolis. Using these maths, we can see how the currents, for example, change the direction going from the equator to the North Pole, going to the right side. And in the opposite way, if we go to the south. And this is possible because the spin of the planet, so the rotation that it has, is not particularly slow. We are moving with the planet at the velocity of 1,670 kilometers per hour. I don't know how many miles it is per hour, but I'm sure that it's faster than Max Verstappen at Monza. And this spin that we can see from the International Space Station is created by the formation of the planet. So when the planet is formatting, starts this little movement that creates the spin, and year by year, eon by eon, this generates the planet and contains this initial movement, so the planet at today continues with this spin. I said before that if we go from the equator to the north, we get to the right, and to the south is the opposite, but it's not that easy to see with the currents. But we can understand better this example with another one, explaining how it works with a spaceship. If we imagine that we go from the equator to the North Pole in a spaceship, we can understand that if we are inside of it, we're gonna go in a straight line from the equator to the North Pole. But if we imagine one person on Earth, this person is gonna see how little by little the trajectory of this spaceship change, going to the right side. This is because the Earth is spinning in one direction, so when we see how it moves, it's not in a straight line, but it's gonna rise little by little to the right part of the North Pole. And it's the same if we go to the south, because it's moving, we're gonna arrive little by little to the left part. So if we put these two ideas together, so someone that comes from the North Pole to the equator and someone that goes from the equator to the North Pole, we see how it creates a cycle. And that is the thing that works with the currents, or also the atmosphere. So when one water mass starts going through the north, starts to change the trajectory and rotates in one direction. And the currents that come from the north through the equator starts to rotate in the other direction, and this creates the gyres. Of gyres, we can have many examples of the North Atlantic subtropical gyre or South Atlantic subtropical gyre, or we have different gyres in the different oceans that we have, but this is an effect that we have from the Coriolis. And with this example of the spaceship, we can see how Coriolis is an effect, so an apparent movement of an object. so it's not a force. But sometimes in oceanography it's easier to consider as a force. This is because we can study different parts or different magnitudes of the ocean, taking in consideration Coriolis as a force. And with that, we can study the things called geostrophical flows. So the geostrophical fluid is going to take in consideration the gravitational force of Earth and the spinning. So in this way, we consider the spin as the Coriolis force. And this is useful, for example, in the calculation of the inclination of the surface water of the ocean. And we can put in 2 points the gravitational force and the Coriolis force and see how the water masses is coming through the coast or going outside of the coast. This helps to understand how the altitude of the water is changing. So if it's decreasing or increasing for a few centimeters in a large quantity of kilometers of surface, we can distinguish between a normal movement of the ocean waters, or in this case the climate change and how the sea levels are rising. This is a topic that we will explore in a future video, but it's interesting to know that we have different ways to measure this and how calculating other phenomena we can understand when is each one occur. Another important knowing effect that we can consider Coriolis as a force is the Ekman spiral. Here we can consider a wind that comes parallel to the coastal line, and we will have an effect from the surface water that starts to spin. And this spinning goes into the deepest part of the same water mass, and this starts to move the water forward from the coast, or in some cases into the coast. But if we take this example of the surface water going away from the coastal line, this creates a gap, and here the water from the deepest part of the ocean in the coast will take this gap, and the nutrients that these waters have are gonna start to create the upwelling, this phenomena that generates a lot of nutrients, so a lot of activity in the initial parts of the food web. And all this is occurring on Earth. And I say something before that you need to keep in mind that helps to this. That the Coriolis effect works when something is spinning. And we have all the planets outside of Earth that also have a spin and also have atmosphere. Maybe not the oceans that we have, but we can have this atmosphere and consider it as a flow. And here, depending how fast or slow the planet moves, we will have more or less Coriolis. If the planets move so slow that Coriolis cannot work, for example Venus, this effect is going to be impossible. But in other planets, as Jupiter, we have this red eye that is a formation for the Coriolis force. And we can see how this is a gigantic gyre that is a lot of time bigger than Earth, but is the same effect, changing the gravitational force and changing the density of the atmosphere. But we can use the same maths to calculate this phenomenon. And this helps to understand how the science works, because in the beginning, this helps to understand the movement of the objects in a spinning surface. Then we can use the same maths to calculate the flows in the atmosphere and the ocean. And today we can use to calculate also in another planet. So extrapolate the knowledge that we have from one field and use it in another ones. This is the incredible part of developing science. That is all for today. I really want to explore this topic in detail and explain with different examples how Coriolis works, not only here but also in other worlds. I hope that now you get what is Coriolis, and if you like this video, share with more people and subscribe to the channel. And I will see you in the next video. Bye bye!